Hey guys, today we're going to talk about some polynomials, which is a very part of precalculus. We're going to start with number 2, letter A. It says, given the following roots, write an equation of the given polynomial and sketch it. So first of all, if you have the roots, 2, 3, positive and negative 1, to find the polynomial, you always write x minus the root. X minus 2, x minus 3, x minus 1, and x minus a negative 1 would really be x plus 1. The reason this works is if you think about going backwards, if you have a parabola like x squared minus x minus 20, and you set it equal to 0, you would factor it into x minus 5x plus 4, and then when you solve x minus 5 equals 0, you get a root of 5. When you solve x plus 4 equals 0, you get a root of negative 4. The roots, when you take the roots and write x, subtract them from an x, it gets you to go backwards. So that's what we're doing here. So let's multiply these two polynomials together. That'd be x squared minus 2x minus 3x plus 6, which is x squared minus 5x plus 6. Let's multiply these together. X squared minus 1x plus 1x minus 1. That's x squared minus 1. Then finally we'll multiply all of these together. So take your time, distribute the x squared. That's x to the 4th minus x squared. Distribute the negative 5x. That's negative 5x cubed plus 5x. And then finally distribute the 6. That's 6x squared minus 6. My suggestion to you to avoid any errors would be to use the box method. When you get crazy polynomials that you're multiplying, x squared minus 1 can be split up on the side of the box, and then x squared minus 5x plus 6 can be on the other side of the box. It helps you to organize your work. So then you could see x squared times x squared is x to the 4th. Got it. X squared times negative 5x is negative 5x cubed. Got it. X squared times 6 is 6x squared. Got it. Negative 1 times x squared is negative x squared. There it is. Negative 5x times negative 1 is 5x. Here that is. 6 times negative 1 is negative 6. So then let's look for some like terms. X to the 4th and negative 5x cubed have no other like terms. Negative x squared and 6x squared is 5x squared. 5x doesn't have any like terms. Minus 6. So that's our polynomial. So now let's talk a bit about sketching. We talked the other day about the highest term in the polynomial. Actually, let's first do this. The last number, the constant, is the y-intercept. So let's graph that. Negative 6. So 0, negative 6. The sign of the x to the first term tells you the slope at that y-intercept. So the y-intercept was negative 6. Because this x to the first term is positive, we're going to go through this y-intercept in a positive sort of way. Next, let's jump out to this highest degree term. Since it's even, that means the e's or the n's are going to go up, up, or down, down. If it was odd, they would go opposite. Now, because the lead coefficient is positive, we know that the graph is going to exit a positive way, which means up. So it needs to also start up. So if this was a negative 1, it would be leaving going downward. Now the last thing we need to do, in these questions today we have the roots. Negative 1, 1, 2, and 3. So really all we need to do is go through all of these roots. And note that this highest exponent, minus 1, 3 in our case, is the maximum amount of peaks and valleys. So watch this. Let's go through this point here, go up through this, back around, down. If you look, 1 valley, 1 peak, 1 valley, 3 peaks and valleys. Let's try that in another question. Let's look at 2c. 2c has some imaginary roots. X equals 2, and then negative 3 plus or minus 2i. So to handle this, we're going to do x minus 2 like we did before, but now be very careful. You're going to do x minus, in parentheses, negative 3 plus 2i, and then you're going to do x minus, in parentheses, negative 3 minus 2i. I know this looks very confusing with all the parentheses, but it's the easiest way to avoid making an error. This is negative 3 plus 2i, that's right here after a minus sign, and negative 3 minus 2i is right here after a minus sign. Next, let's get rid of one of these sets of parentheses by distributing the negatives. So this will say x plus 3 minus 2i, and this is x plus 3 plus 2i. And this x minus 2, just, we drag it along. Now let's very carefully distribute this x first. X times x is x squared, x times 3 is 3x, x times 2i is 2xi. Now when I distribute this 3, I'm going to make columns of like terms. 3 times x is an x term, 3x. I'm going to put it under this x. 3 times 3 is 9. I'm going to put it out here because there's no other numbers here. 3 times 2i is 6i. This is just an I term, which is not like an xi term. And then finally, let's distribute this negative 2i. Negative 2i times x is negative 2xi. That goes in this column. Negative 2i times 3 is negative 6i. Negative 2i times 2i is negative 4i squared. Now what should happen is this. All of your I terms should go away. These cancel, and if you think about it, you've learned in Algebra 2 that I squared is negative 1. So this is really negative 4 times negative 1, which is 4. So we have x squared plus 6x plus 9 plus 4, which is x squared, plus 6x plus 13. And an x minus 2. I think I'm going to go on to a different page to finish this. So we have x minus 2, and then this all reduces to x squared plus 6x plus 13. Alright, let's continue this. X minus 2, x squared plus 6x plus 13. So let's do some distributing. Distribute the x cubed plus 6x squared plus 13x. Distribute negative 2, negative 2x squared minus 12x minus 26. X cubed, combine these, that's 4x squared. Combine these, that's 11x minus 26. Now let's graph this. This, of course, is the y-intercept. Make sure you label everything. 0, negative 26. Oops, sorry. This positive in front of the x to the first is the slope at that y-intercept, so positive again. Because this is an odd, it's going in different directions, and furthermore, because this is a positive, it needs to leave going upward. So if it's going to go in different directions and leave upward, it needs to start downward, and we need to go through our roots. Now our only real root was 2, because the other roots had i's in them. Because this is a 3, 3 minus 1 is 2, there's 2 peaks and valleys. So if you follow this along and go through everything, it's going to make a line almost with no peaks and valleys. So sometimes when you have imaginary roots, you have to add an extra peak and valley in on your own. Always make sure that when you subtract 1 from the highest exponent, you have that many peaks and valleys. So let me know if you have any questions. Please attend the meet. Have a great day.